Number 48. A woman is 5 foot 6 inches tall and walks at a rate of 6 feet per second away from a streetlight that is 18 feet above the ground. When she is 20 feet from the base of the light, at what rate is the length of her shadow increasing? So, first thing I'm going to do is, I see our answers are in feet per second, and this length is 5 foot 6 inches. So instead of saying 5 foot 6 inches, I'm just going to quickly correct that, or not correct it, but change it to just 5.5 feet. So, in this problem, there are two things that are changing, and they're not the heights of the people. They're, in fact, the distance from the lamppost, is that what it is? The street light to the person, which I'll call X, and the distance from a person to the tip of their shadow, which I'll call Y. And we actually have two similar triangles here. We have this big triangle with this is 18, and over here this would be X plus Y. And then this smaller triangle with height of 5.5 and a base of Y. And so I can actually set up a proportion using these similar triangles. The proportion I'm going to use is I'm going to use the height and then divided by the base. So for the big triangle, it would be 18 divided by X plus Y. And then for the second proportion for the small triangle, it will be 5.5 divided by Y. So if we want to solve this, we can just cross multiply. So 18y equals 5.5 times x plus y, or 18y equals 5.5x plus 5.5y, or, let's see, 18 minus 5.5, that's, 12.5y equals 5.5x. So what are we actually trying to solve for? Let's remind ourselves. At what rate is the length of her shadow increasing? So we're trying to find the rate as y increases. So I'm actually going to solve for y. In that case, I'm going to solve for y. I'll say y equals 5.5 over 12.5 times x. So this is about rate of change, and so naturally this is where you get some calculus concepts. And so I'm going to take the derivative with respect to time on both sides. So the derivative of y with respect to time, well, that's just dy dt. And that's in fact what we're solving for. We're finding the rate as y changes with respect to time. And then if we divide these, you'll get a decimal, I believe. 5.5 divided by 12.5. So yeah, 0.44. 0.44, and then times, well, and then the derivative of x with respect to t, like that. So we have a new equation. So now we can find the rate that the shadow changes with respect to time if we know the rate that she moves away from the street light, which we know because it tells us that she walks at a rate of 6 feet per second. So dy dt will be 0.44 times dx dt, the rate at which this distance changes, which it tells us is 6 feet per second. So to get my answer, all I have to do is take 0.44 and then multiply it by 6. So take this, multiply it by 6, and so hopefully, if I have done everything correctly, we'll get 2.64 feet per second. And yes, that is answer choice A. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.